Hello and welcome to today's maths lesson. I remain your favorite maths tutor, Azubike Ulia. And in today's lesson, we will be talking about HCF and LCM, which is the highest common factor and the lowest common multiple. But before we go ahead to the business of the day, kindly spare some minutes of your time to subscribe to this YouTube channel and also click the notification bell so you will be notified whenever we drop a new video. So back to the lesson of the day, HCF and LCM. And before we dive into the business of the day, we are going to look at factors and multiples. Factors and multiples. If a number x divides another number y, exactly. When we say exactly, it means without any remainder. Then we say that x is a factor of y and y is a multiple of x. This is y over x. When x divides y, then x is a factor of y and y is a multiple of x. Now, let us go ahead and take the definitions of HCF and LCM. HCF, which is the highest common factor, of two or more than two numbers. The HCF of two or more than two numbers is the greatest number that divides each one of them exactly. Greatest number that divides each one of them exactly. Now let us look at the lowest common multiple, the LCM. The LCM of two, sorry, let me write this properly, of two or more than two numbers is the least number which is exactly divisible by each one of the given numbers. I'm going to drop a little hint here. Take note of the hint. The product of two numbers is equals to the multiplication of their HCF by their LCM. Take note of these things. The product of two numbers is the multiplication of their HCF by their LCM. Now, let us look into the methods of determining the HCF and the LCF of numbers. And there are two methods of determining HCF and LCM. There are two methods. First, we have the prime factorization method. And we have the division method. Let's look at the prime factorization method. Take it one after the other. Let's take the prime factorization first. Now, this is an example. Determine the HCF and LCM of the following numbers. One 44, 180, and 108. Now, we are going to determine this using the prime factorization method. So how do we go about this? Now, 144 is the same thing as 2 times 2 times 2 times 2 times 3 times 3. This is the prime factorization method. 144 is the same thing as this. 180 is 2 times 2 times 3 times 3 times 5, and 108 is 2 times 2 times 3 times 3 times 3. So how do you find the highest common factor from this? What you do, you wash out for the number that appears in all three. You wash out for the factors that appears in all three numbers. Example, 2 is here, 2 is here, and 2 is here. You circle it out. 2, 2, 2. Another 2 is here, is in 144, is in 180, and is in 108. Circle it out. Look at 3 here, 3 here, 3 here. You circle it out. 3, 3, 3. Yes. Look at another 3. 3 is here, and is here. So the HCM becomes this first 2 times this second 2 times 3 times 3. These factors appear in all three in all three numbers. So this becomes their HCF, which should be 36. Then how do you find their LCM? The LCM will be, we write down the HCF 2 times 2 times 3 times 3. Then you add these other numbers that are not in the circle, times 2 times these 2 times this 3 times this 5. These other ones that are not in the circle, you write them down, and this becomes 2160. This is the LCM. Don't know if you get me. It's very easy. First of all, you find the common factors in all three numbers. This is 2, 2, 3, 3, and you write them down. That's the HCF. Then for the LCM, you write down the HCF first. This is the HCF, you write it down first. Then you include these other numbers that were not in the initial mix of the HCF. You add them all up together and multiply everything, and it becomes the LCM. That is prime factorization method. Now we are going to look at the division method. Division method. Now find the LCM and HCF of 15, 30, and 90. Solution. Let us find the LCM first. LCM. Long division method. This is 15, 30, and 90. First of all, we look at the three numbers and we start from 2. We start from the lowest number, which is 2. Forget about 1, start from 2. We look at these numbers and we determine if there's any number among these three numbers that can be divided by 2. Yes, 30 can be divided by 2, 90 can be divided by 2. So let us divide 2. 15, 2 cannot divide 15 without a remainder. And take note, what you are looking for is a factor that will divide these numbers, without a remainder. So 2 will not divide 15 without a remainder. So you write down 15. You cannot divide it without a remainder. You bring down 15 down because 2 cannot divide it without a remainder. But 2 can divide 30 without a remainder. 2 divided by 30 is 15. 2 divided by 90 is 45. Don't know if you are following. Then when you look at this number, you find out that 2 can no longer divide anything here. 2 can no longer divide anything here. Let us try 3. Will 3 divide? Yes, 3 will divide. 3 will divide 15 to become 5. 15, to divide this 15 to be 5, divide this 15, 5, divide 45 to be 15. Can 3, we look at this number again. Can 3 divide anything here? Yes, 3 can divide 15. We put down 3. 3 cannot divide 5 without remainder. We write down the 5. 3 cannot divide this 5 without a remainder. We write down the 5. 3 can divide 15 to become 5. 3 can divide 15 to become 3. 3 will divide 15 This will be 3. Can 3 divide any other thing here? Yes, 3 can divide 3. We write down 3 again. But it cannot divide this 5. You cannot divide this 5. You write down 5. You cannot divide this 5. You write down 5. But you can divide 3 to give 1. What again can divide this remaining numbers? We find out that it's 5 that can divide what is remaining without a remainder. So 5 divided by 5, 1. 5 divided by 5, 1. And this is 1. Basically, the idea is to divide everything until we are left with 1, 1, 1. So from here now, the LCM becomes, we multiply all these numbers together, comes 2 times 3 times 3 times 3 times 5. Okay. Hold on, let me see if I made a mistake. It's looking like I made a mistake. No, there's no mistake, which will be I made a mistake. Sorry. This is 5. 3 divided by 15 is 5. Sorry about that. So this will be, sorry, let's just start afresh. Let's start afresh. Sorry. Deeply sorry about this. Let's do it again. Let's figure it out again. My bad. This is 15, 30, and 90. Okay. So 2 will divide 15. 2 can't divide 15, so we put down 15. 2 will divide 30, this is 15. 2 will divide 40, 90 to become 45. 3 will divide 15 to be 5, 5 and 15. 3 will go again. This is 5, 5, 15 divide, 3 will divide 15 to give you 5. Then 5 we divide everything to give you 1, 1, 1. So this is it. The LCM becomes 2 times 3 times 3 times 5. The LCM is multiplication of these numbers, which will be 90. That is the LCM. Sorry for the initial mistake. So we now go over to determine the HCF. Now when looking for the HCF, there's a little trick to it. Now when we are deriving the LCM, you notice that even though 2 could not divide 15, we still you used it because it could divide 30 and 90. All you had to do was to put down the 15 you couldn't divide. You understand? In the LCM, when finding the LCM, in as far as the factor can divide any number, any of the numbers we are looking for, then it can go. But in HCF, whatever factor you are using to divide must be able to divide the total numbers without remainder. In this case, whatever factor we are using to divide 15, 30 and 90 must be able to divide each of them completely without the remainder. So if you are using 2 cannot work in this case because 2 cannot divide 15, but it can divide 30 and 90. It will work in the LCM part of it, but it will not work in HCF. In the HCF part, you must use a factor that can divide everything completely. So when we look at these numbers 15, 30 and 90, we will find out that 3 can divide everything without remainder. 3 will divide 15 to give 5. It will divide 30 to give 10. It will divide 90 to give 30. When you look at it, when you look at what is remaining, you find that 3 can no longer work because 3 cannot divide 5 without a remainder, and it cannot divide 10. But 5 will do the job. 5 can divide everything here without a remainder. 5 will divide 1. 5 will divide 5 to give 1. 5 will divide 10 to give 2. 5 will divide 30 to give 6. And we'll be left with 126. And when we look at this 126, we will discover that there is no other thing that we can use. There is no other factor we can use to divide everything here completely without any remainder. And that is the end. We have come to the end of the road because nothing else can be done. No other factor will divide these 3 numbers completely without a remainder. So we stop here, and this becomes the HCF of these numbers 15, 30 and 90. So the HCF becomes 3 times 5, which is 15. That is the HCF. When looking for the HCF, you must look for factors that will divide every single number completely without a remainder. But in the HCF, when looking for LCM, you will look for a factor that can divide even 1 or 2. You look for a factor that can divide any one of them, not compulsorily all of them, any one of them. But in the HCF, it is compulsory that the factor must divide all of them completely without the remainder. I don't know if I'm making sense. I'm trying to explain it in the best possible way. So that is it for the division method. Then we'll go ahead and talk about the HCF and the LCM of fractions before we round it up, before we call it today. HCF and the LCM of fractions. Now, the HCF of a fraction is equals to the HCF of the numerator divided by the LCM of the denominator. Take note of this formula. Take note of these formulas. Then the LCM of a fraction is equals to the LCM of the numerator over the HCF of the denominators. Take note of this little formula here. This is the formula for finding the HCF and the LCM of fractions. So let's look at an example. Find the HCF and LCM of 1/2 and 3/4. Remember that the HCF of a fraction is equals to the HCF of the numerator over the LCM of the denominator. In this case, the HCF of the numerator is 1 and 3. That is the HCF of 1 and 3 divided, the denominator is 2 and 4, divided by the LCM of 2 and 4. HCF of 1 and 3 is 1, and the LCM of 2 and 4 is 4. So the HCF of these two fractions becomes 1/4. That is the HCF. Now we'll find the LCM. The LCM from the formula of the fraction is LCM of numerator over HCF of denominator, which is the LCM of 1 and 3 over the HCF of 2 and 4. The LCM of 1 and 3 is 3, and the HCF of 2 and 4 is 2. So the LCM of this fraction is 3/2, and that is how to determine the HCF and the LCM of fractions. And I hope this lesson was understood. I'm sorry for the little mix-up we had earlier. I'm sorry about that. Thank you for watching. Thank you for sticking around till the end of this video. Thank you for your time. Don't forget to subscribe to our YouTube channel and then to hit the notification bell so you will be notified whenever we drop a new video. And I look forward to seeing you in the next class. Bye.